This is the video for 1-3b. I can find the area of a circle sector. In order to talk about the area of a sector of a circle, or a circle sector, I just want to first remind us how to find the area for the whole circle. So just in case we happen to have forgotten, the area for a circle, the formula is area equals pi r squared, where pi is 3.14 and r in that formula is the radius of the circle. So when we talk about the area of a sector, it's basically the area of just a piece of the circle that is subtended by or cut off by a central angle. So in terms of our previous standard, which was discussion for arc length is the length of a piece of the circumference, or a fraction of the circumference. Area of a sector is just the area of a fraction of the circle. So again, the key is to think about what fraction we have. Okay, so that's going to be what our goal is. We can do this in degrees with this subtended central angle being measured in degrees, and we can also do it with the subtended angle being measured in radians. So let's take a look at each of those formulas. So let's do degrees first. So if I want to talk about the area in degrees, we know that the area of the sector is equal to some fraction of the total area. So I'm going to put my total area formula here, and then the fraction that we're speaking of goes there. And think about the circle. The whole circle in degrees is 360 degrees. So I need to know what fraction of it we're speaking of. So again, here's our circle. It has some subtended piece. We'll call it that guy right there. So we're looking at what is the area of this region. Okay. So this central angle right here, which again I'm going to refer to as theta, is the angle that is important because that's what piece of the circle we have. So in our formula, we're going to say it's whatever theta is, 10 degrees, 50 degrees, 130 degrees, out of 360 times pi r squared. So if you can find the total area and you know the measure of that central angle, then you can go from there. Not too bad, at least I don't think so. Where it becomes slightly more interesting, though, is if we start to think about it in radians. So let's do that. Let's move this over here. So to think about the area of the sector in radians, I'm going to do a similar thing. I'm going to start talking about the area of my sector and sometimes I'll just say area, and then as a subscript I'll write sector equals. So again, it's some fraction of the total area, which has the formula of pi r squared. And again, it's what fraction. So I need to remember in a circle, 360 degrees, come off to the side to write that. So 360 degrees is equal to 2 pi, or about 6.28 radians. So if I want to talk about a fraction of the circle, I'm talking about how much out of that 2 pi do I have. So there's my formula. And then again, just like with the arc length piece, if I think about multiplying these together, make that second guy into a fraction, I now see that the fraction that I have is theta pi r squared over 2 pi. And within that fraction, I have a pi in the top and bottom, so it will cancel. So just like with arc length, the area of a sector in radians, the formula also simplifies. So we can say that it's 1/2, I'm just going to pull that 2 out, theta times r squared. So we can move this being 1 theta pi r squared up here, and then I can pull the 1/2 out and just write it as 1/2 times theta times r squared. So that is our formula for the area of the sector of a circle. Where theta is the measure of the central angle in radians, and r is the radius of that circle still. So now I want to take a look at a couple of examples of how we can use this, or how we will be asked to use this. So let's see if we can do that. Let's make my examples a bit bigger. Alright, so let's come back to this guy over here. Or not. Let's try this one. So find the area of a circle sector subtended by an angle measuring 5 radians. So that's important. So the angle is 5 radians, and the radius is 28 feet. So I know that this is the area formula in radians, so I want area equals 1/2 theta r squared. So first pick the right formula. And in this question, they have told me that the theta, the angle, is 5 radians, and the radius is 28. So now it's just a matter of plugging that in. So I have area equals 1/2 times 5 times 28 squared. I don't know what that is off the top of my head, so I will go to my calculator, and it will tell me 28 squared times 5 times 1/2, and I get that the area equals 1,960. The unit should be the same units as the radians, so I get feet, but it's area, and I did feet times feet in my units when I was in this step. That gives me feet squared. So my area final answer is 1,960 square feet is the area of that sector of the circle. So if I had a picture that represented that, this guy right here would be 28, and for 5 radians it probably would be something sort of like this-ish. So that was the area of where this angle is 5. And I was finding the area of this whole big piece. I know it's big because I know there's 6.28 radians in one circle, so 5 is almost all the way there. Let's see if we can try another one. Find the area of a sector of a circle of radius 5 feet. Oh, sorry. If the area of a sector of a circle of radius 5 feet, I need that, is 50 square feet. So the area is 50 square feet. What is the measure of the angle subtending the sector? So again, they haven't told us what units they want the angle in. So I'm going to go with radians, just because we're going to live mostly in radians in this class. So I'm going to say that the formula that I want is area equals 1/2 theta times r squared. They told me that the area is 50 square feet, and that the radius is 5 feet. And what we want to know is, what is the angle? So always trying to interpret what do we have and what do we need before we start figuring that out. So I'm going to plug what I have into my area formula. So I have 50 equals 1/2 theta times 5 squared. So I have 50 equals 25 over 2, which maybe you change into a decimal, and that's fine, times theta. So that's the 5 squared, which is 25, times 1/2, which gives me 25 over 2. And then to solve, just because I don't have a calculator easily ready, I'm going to multiply both sides of this by the reciprocal of this fraction to try to cancel it out. Multiply by the reciprocal, its inverse, it undoes it. So for a final answer, I get that theta, on this side these cancel, and these cancel, And on this side, I know that 25 goes into 50 twice, so I actually don't need my calculator here. I get that theta equals 2 times 2, which is 4, and again the units here is radians because I chose the radians version of the formula. And that is finding the area of a sector of a circle in both degrees and radians.